Section 10.4 is tangent ratio. We're still working with right triangles, and this is the start of trigonometry, which basically works with the sides and the angles of a right triangle. So when you talk about a trigonomic ratio, you're talking about the ratio of two of the sides of a triangle versus one of the angles of the triangle. And so when you're talking about an angle, such as this angle right here, you label or signify what the two legs are of the triangle. The side that is opposite, or the leg that is opposite that angle, is called the leg opposite. The leg that is next to or part of the angle, now the leg, is called the leg adjacent or adjacent leg. And of course, don't forget, the longest side is always the hypotenuse. When you are talking about one of the angles of a triangle, of a right triangle, and it doesn't matter what the angles are, but we're going to call this A and this B and this C. So the side that is opposite of capital A angle is usually considered lowercase a. The side that is opposite the B angle is the lowercase b, and then the side opposite the C angle, or the 90-degree angle, is side C. Okay, so we use these for the Pythagorean theorem, a squared plus b squared equals c squared. So it's the same labeling as that. Now, the trigonomic ratio that we're talking about today is called tangent. They signify that as just T-A-N, so it's not tan, it's tangent. And the tangent of the angle, let's say the tangent of A, is always the opposite leg over the adjacent leg. So that's the ratio that you're always using. So the tangent of the angle A is A over B. Now, if you are actually talking about the B angle, so if you say the tangent of B, then you would use the opposite of that, which is B, and the adjacent leg would be A, because this side is next to B. Okay, so you have to refer to the angle that you're talking about to label the sides. Okay, so here we have, it says find the tangent of S and the tangent of R. Well, we know that the tangent is always, I'm going to write it here, the tangent of an angle is always the opposite leg over the adjacent leg. Okay, so when we are looking at S, the opposite leg is here. So 4 square root of 3. The adjacent leg is 4. So that's why we put 4 square root of 3 over 4, which of course just becomes the square root of 3, which is approximately a decimal. You could type that in the calculator. Now, when we are talking about angle R, I'm going to erase this. When you're talking about angle R, the opposite side now is the 4. And the adjacent leg is the 4 square root of 3. So it's the reciprocal of the first one, which of course is 1 over the square root of 3, which is approximately, and then you could find the decimal. So the point is, depending on which angle you're talking about, you are talking then about particular side that's opposite that angle and adjacent to that angle. So you have to understand what those mean. You can use the tangent function on the calculator to approximate the tangent of an angle. You can also use the table. Well, I would suggest you use the calculator if you have one, or you could find one online. But if you wanted to find the approximate tangent of 74 to 4 decimal places, you would type in on your calculator. Now there's two things you have to be careful of, or one thing for sure you have to be careful of. But when you type in the tangent of 74 on your calculator, it's possibly going to give you the wrong answer. So if you have a graphing calculator, the first thing you should do is go to mode. If you go to mode on your calculator, the third line down says radian or degree. You want the degree highlighted. So you'd have to go down and over to degree and push enter. Now when you go back and you find the tangent, the tan button of 74, it should be 3.48741 in 4 decimal places. So it should be that. If you had it in radian mode, it's going to be incorrect. So you have to change the mode on your calculator. Okay, find the tangent of S and the tangent of R. The tangent of S is here, which is opposite 6 over adjacent 8, which is 2/3. Oh, I'm sorry. 3/4 or 0.75. The tangent of R, this time I'm looking at R, the opposite is 8, the adjacent is 6, or 4/3, or 1.333. Okay, so for this one, the tangent of S, you're looking at S, the opposite is the 6, the adjacent is the 8, so it's 6 over 8. All right, for this one, the tangent of S, opposite is 10, adjacent is 24. Now the hypotenuse you have to pay attention to because you're not using it with tangent. The tangent of R, opposite is 24, adjacent's 10. Okay, and then you just type these in your calculator. The tangent of 35, so tangent 35, 0.7. Once you have it in degree mode, you shouldn't have to change it out of that mode unless you had to replace the batteries or something like that. Tangent of 85, 11.4300, actually 01. And the tangent of 10 is 0.1763. Use the tangent ratio to find the value of x. All right, once we find the tangent ratio of, we're going to obviously use this angle since that's given to us, equals opposite over adjacent. In this case, the adjacent is x. If I find x, and x is on the bottom, so the denominator, all you have to do is switch x and then the tangent of 22. Then you would divide by 3 by the tangent of 22. So I'm taking basically 3 divided by the tangent of 22 on my calculator. So 3 divided by tangent 22, I get 7.4, and it says to the nearest tenth, so 1 decimal place. So according to this, x is about 7.4. Now, there is a difference. What if x was in the numerator? And I hope they have an example on that. This time, 2 different tangent ratios to find the value of x to the nearest tenth. Okay, so what I'm going to do is, I know this one's 35. This one has to be 55 because they have to add up to 90 degrees. So what we could have done was said the tangent of 55 is equal to x over 4. We also could have said the tangent of 35 is equal to 4 over x. So it's very important you understand how to do this and what the difference between an opposite and adjacent are. If I'm going to find the value of x because it's in the top or the numerator, all I'm going to do is multiply both sides by 4. Those two cancel out, so x is equal to 4 times the tangent of 55. So I would then calculate that on the calculator. This one, because the x is in the denominator, I'm going to switch those. So it's actually 4 divided by the tangent of 35, which again I would put into my calculator. So I should get the same answer no matter which way I do this. 4 times the tangent of 55 is 5.7. If I take 4 divided by the tangent of 35, I get also 5.7. So x is the same no matter which way I do that. You have a 45-foot length from where you're standing to the base of the tree. Okay, so you have a right triangle here, 45 feet. And you know this is a 59-degree angle, and you want to find the height of the tree. Well, I would say then that the tangent of 59, is equal to opposite over adjacent. So h is equal to, I'm going to multiply by 45 to the tangent of 59. I'm going to type that in my calculator and I'm going to calculate what that would be. 45 times the tangent of 59 is 74, let's see, to the nearest foot, so 75 feet. So that tree is 75 feet tall. Okay, so hopefully you understand how to do this. I'm going to go through some of these. You can pause the video and see if you get these right. And I will go ahead and go over this when you're ready. Okay, welcome back. Number 6. If I'm going to use this angle, the opposite is here. The adjacent is here. So the tangent of 44 equals 8 over x. Now what I could have done was I could have used this angle, which would have been 46, sorry about that, got to add right, 46, so I could have said the tangent of 46 equals x over 8. Because the x now is the opposite and the 8 is adjacent. For this one, I would say the tangent of 34 equals 7 over x. If I have x in the bottom, I would just switch those. So 7 divided by the tangent of 34. And that's how you do those. So hopefully you were able to get those two correct. Hopefully that would help you find the rest.